of the things is space-grade electronics, they basically worked out aren't necessary. For things only going to run for about a year, and then it's probably going to die. But in a year's time, the technology will have moved on anyway. So why make a space-grade satellite that's going to last for 20, 30 years if it's for educational use? Just have something that maybe lasts a year, use the standard electronics, and then in a year's time, you can just re-enter the thing, run it up, and put another one up there. And the second thing is because they're using the standard Arduino platform, so this board here is the main processing board on the Arduino. Basically, each one of these here is one of these, a much more powerful one. And they have, I think they have 15 Arduinos on one board for each board. These boards you can buy, you can use them on the ground as well. So my friend John in Melbourne has developed this board and these 4 boards as well. He's developed a power board, the main board, and this is an adapter board which allows them to take a board like this and put it onto the Arduino board and use it in the same type of system. And this is a prototyping board for them to develop any project they want. Little speaker here, Higstone speaker, but you can also turn that around the other way to a sensor and it becomes a knock sensor, so you can detect vibrations and knocks. Kids can make little coded door entry systems. You know, you have to knock on the door with a special code and it will open the door. It's kind of fun. And there's a real-time clock on there, which is a super accurate clock. So if you want to do timing of anything, that's a real-time clock there. So I'll pass that around. That has our own little Arduino board on there as well. We've decided to move away from the shields and actually go to a much smaller board there, which could be put onto a breadboard. So I'll pass that one around.
A lot of students, when they're doing their EEIs, they need to, experimental investigations, they need to take data over a period of time, and if they're using some basic data loggers, and often enough they're just standing there, and they're only able to take data over a period of time that they're actually there. So being able to hook this up as, would you be able to hook this up to basically take readings over, let's say, a couple of days period, recording every
So you can just write it to an SD card. So one way that people do it, you can put an SD card reader on the board. The other way is to connect it to a network and then write maybe a little web service or something like that, or push the files across into a website. But the simplest way is to just use an SD card and write basically CSV data, and then they just, when they finish their experiment, they eject the SD card and they might just put it into an SD reader on the PC. And they just plug that in and then they read it. So you can put in sort of batteries on things. And yes, it says this would run for potentially years if you were just running. Because what you can do with the little boards, you can put them into some kind of sleep mode and they're not doing things. Just fire them back up again and get it going and then shut them down again. But most of the time, if you're just on a PC, like if it's in a lab and you've got a PC, you could just leave the PC on all weekend, plugged into with a cable to your experiment, and then you wouldn't even need the SD card for that. You could just log it directly to the PC, write a little program on the computer to actually just pull that data. There's probably lots of different ways. But one of the things we also thought about, particularly for science, was we could have basically like a sensor dock that this thing could plug into. It might be about the same size as that, potentially. And that might have a whole load of standard, maybe you have all the cheap ones on there by default, and then you have some extra plug-in sockets for the more advanced ones. And you have it so that they're all labelled, so it's really easy. Like for instance, the pH sensor, it's got the exact pins on there, so you can only put it one way around, so you can plug in that pH sensor. Because I'm conscious of the fact that you want to actually do science, and don't want to actually teach a massive amount of electronics to get to where you want to get, so you might be doing that in another course. That might be another electronics course you have, but we want to actually do science. So having something that makes it really easy for people to actually get started. So that's one of the things we were thinking about doing later on. But at the moment we haven't got a lot of data about how people are using them at the moment. So what we want to do is try and get these little Arduinos out to people and get them using them. So Andrew's already bought a few from us for Somerset, so they're going to do another.
Just having attended the Arduino electronics workshop, fascinating stuff in terms of the possibilities for extended experimental investigation and data collection investigations that students are doing at school. Wow, you know, the range of possibilities is amazing. Previously I've found teaching science and chemistry is that the range of experiments that the students are able to do are very limited in terms of the data that they can collect and the I guess the equipment that's available to them, but all of this Arduino electronics stuff makes it all so much more possible. And yeah, I think the kids would really engage with it, and it would the investigations would take on a whole new level and be so much more interesting than what they're actually currently able to do. So yeah, very, very impressed with all the Arduino electronics stuff. Great.